Hello friends, welcome back to my YouTube channel. So today we'll be talking about differentiation of implicit function in calculus. So I have two questions here. The first one says, find the y over the x if x y squared plus 2y is equal to 1. And the second one says, x squared minus xy is equal to 4y squared. So for me to solve this first one, so I'm going to consider xy square as a product and 2y as a composite function. I'm going to apply chain rule here in the first one, the first term. So I have x y square plus 2y is equal to 1. So applying chain rule here, I'm going to have in the first one, which is xy square, I'm going to keep x here and differentiate y square, the y square over the x, then plus, I'm going to keep y square and differentiate x times the x over the x. That's how to apply chain rule. So because this is implicit function, you remember we have two variables, x and y. So plus, I'm going to differentiate 2y, that is the 2y over the x, then is equal to, I'm going to differentiate constants. I remember if you're differentiating constant, is always 0. So 1 is a constant here. So its derivative is 0. Now, the next thing to do is to write this. So differentiating y squared is going to give me 2y. So I'm going to write x times 2y. And remember, we're looking for the y over the x. So I'm going to write dy over the x, then plus y squared. Then the x is going to cancel out the x. I have y squared plus differentiating 2y is going to give me 2. So I'll have 2 dy over the x is equal to 0. So the next thing to do is to collect like terms, okay? And remember that there is dy over the x here, and there is 2y dy over the x and 2 dy over the x. They are like terms. So I'm going to write, but before that, I'm going to times 2y by x, and that's going to give me 2xy dy over the x plus y squared plus 2 dy over the x is equal to 0. So now the next thing to do is to do the collection of like terms, which is going to be 2xy dy over the x plus 2 dy over the x, because they are like terms. Then I will move y squared across to the right hand side, and that is going to give me minus y squared, because it's plus. Any sign that crosses equal sign in mathematics, the sign changes. So now I'm going to write 2xy plus 2. I'll put brackets. I'm going to factorize because the y over the x is common. That's why I'm putting brackets to write the y over the x is equal to minus y squared. So to find the value of dy over the x, I'm going to divide across with each coefficient, which is 2xy plus 2. So dividing across with the coefficient 2xy plus 2, 2xy plus 2. So this 2x is going to count, 2xy plus 2 is going to cancel out. So I'll have dy over the x is equal to minus y squared over 2xy plus 2. So that is, so in this case, the value of dy over the x is equal to minus y squared over 2xy plus 2. So that is the answer. Let's also apply implicit rule. So I'm going to do the same in the second question, which says, find the y over the x if x squared minus xy is equal to 4y squared. So I'm going to write x squared minus xy is equals to 4y squared. That is the second question. X squared minus xy is equal to 4y squared. That is the second question. So for me to apply this implicit rule, I'm going to do the same. Okay, so I'm going to do the same, considering that I have two variables. It's something I did in the first question, considering I have two variables, x, y. So I'm going to apply chain rule here in x, y. So, but before that, I'm going to write the x squared over the x, differentiating x squared minus, so I'll put bracket because I have two variables, x and y. So applying chain rule, I'm going to have, I'll keep x and differentiate y, and that's going to give me the y over the x. Then plus, I'll keep y and differentiate x, and that's going to give me the x over the x. Okay, so is equal to, I'll close the bracket, is equal to, then I'll differentiate 4y squared over the x. So that is the first thing to do. So now this is the same thing as, then differentiating x squared is going to give me 2x minus, then put bracket. I put bracket because of this minus sign, because I'm going to add these two terms. That is x dy over the x plus y dx over the x. So the essence of putting brackets, the essence of using parentheses, is for the minus outside the bracket to affect the plus inside the bracket. So I'm going to have here, I'm going to write x dy over the x, then plus, remember here the s is going to cancel out the x, I'll have y remaining, is equal to, so I'm going to differentiate y squared. So differentiating 4y squared rather, I'm going to have 8y, then remember we're looking for the y over the x. So now this is the same thing as 2x minus bracket. So in this case, I'm supposed to clear the bracket, okay? So I'll write this, and it's y dy over the x. So I'm going to clear brackets, and I'll have x dy over the x. The minus times plus is going to give me minus. Then y is equal to 8y dy over the x. So the next thing to do is to collect the like terms. Okay, and you know that 2x and minus y are like terms in this case, because I'm going to group x dy over the x and 8y dy over the x on one side, because, or rather to one side, because they have dy over the x as a common factor. So this is going to be 2x minus y is equal to 8y dy over the x. So this is plus sign here, minus 8x dy over the x. So it's going to be plus x. On the right hand side, it's going to be plus x dy over the x. So I'll have 2x minus y is equal to, so I'll factorize this. So I'll write 8y plus x, then I'll put bracket dy over the x. Because if I multiply the bracket again, I'm going to get 8y dy over the x plus x dy over the x. So I just factorized, bringing out dy over the x, which is a common factor out of the bracket. So this is the same thing as 2x minus y is equal to, so in this case, I'm going to write dy over the x, because I will divide across with its coefficient, which is 8y over 8y plus x. So that is going to give me 8y plus x. So therefore, the y over the x is equal to 2x minus y divided by 8y plus x. So this is the answer. That's how to apply implicit rule of differentiation. So thank you for watching. Don't forget to subscribe to this channel for more.